The data that we might want to collect ideally will be collected in a multi-sensor and multi-platform and multi-site manner. Eyewitnesses reports, I want to elevate what Dr. Drake said, cannot ascertain the nature of UAPs. However, they should be considered because they may contain important information, for example, persistent sighting locations or seasonality. But they only really work if joined with quantitative data collected by sensors, as well as biophysical and psychophysical assessments of the witness and the impact that the experience has on them to really reveal the nature of UAPs. You've heard it from my colleagues a number of times. The data needs to be collected by sensors. They need to be calibrated or calibratable. So we need to collect not only the data, images, sounds, spectral characterization of what we see, but metadata. The sensor type, the brand of the sensor, the noise characteristics, time of the acquisition, instrument sensitivity, as well as information about the circumstances of the data collection, for example, temperature, or the location, or the conditions in which the sensor is at the time of collecting the data. The data should be collected simultaneously by different platforms, ideally in different locations in a multi-sensor system. So some of the data that we may want to collect are images, but also temperature, sound recording, spectral data emissivity that tells you the color in a very fine grid, as well as monitoring the motion of objects, which has been very important to identify what we have seen as UAPs that have been reported. Much of this certainly can be achieved with professional-grade infrastructure, and both new and existing infrastructure to do that, such as astrophysical and geographical observatories, both on the ground and satellites. Some modern observatories in particular are designed for the detection of time anomalies specifically, as well as for the detection of objects that move rapidly in space, near-Earth objects, asteroids, meteors, etc. So those could be leveraged for the study of UAPs. There is also some effort ongoing in the developing of facilities that are specifically designed to detect UAPs, and many of those comply with the characteristics that I just described. This level of information, though, can also be obtained by the public. We could crowdsource the data collection if a platform to crowdsource exists that supports the collection of data and metadata and the transmission of data and metadata. And we think that NASA might be able to play an important role in the development of this platform. To echo what Dr. Bontempi said, NASA has a wealth of experience in coordinating scientific studies, efforts across discipline and domains, serving as a bridge between communities in the interdisciplinary studies and studies across different countries. All of these can be supported, all of these can be leveraged to support the work of the other agencies in the identification and explaining UAPs. NASA also has a really important experience in data curation. We have heard about the sophistication of the analysis of the data that NASA provides, of the sophistication of the calibration that the data that NASA shares arrives to. We have heard about the open data policy that NASA data goes under. Furthermore, NASA has recently spearheaded an effort to review NASA and NASA partner archival data to prepare them for machine learning and AI, so that data can be served to the community directly and ready to apply AI methods on it. This is an important experience that could be leveraged in the study of UAPs. However, we do want to emphasize that the current status of the UAP data will make this lift really hard compared to even what is being done by NASA for astrophysical data. And finally, I wanted to emphasize what my colleague said. NASA has a great visibility. UAPs are of great power, of great public interest, and this could be an opportunity to really increase the reach of science, help people understand the scientific process, and maybe diversify the scientific community by attracting new talent into the scientific community due to the visibility of the problem. And I think that's all of my remarks.
Questions?
Lots of questions.
Do you want to go, Richie? Okay. So on the whole crowdsourcing front and getting reports from citizen scientists, what are you thinking along those lines? Is it providing a set of guidelines for how you report? Is it open sourcing a set of applications for cell phones to be able to pull in a lot of the right metadata. What does that look like?
Yeah, so I think guidance wouldn't, just a set of guidance of best practices, etc., would just not be sufficient. I think what needs to be provided is a platform. You mentioned cell phones. Cell phones have been used for crowdsourcing, the study and detection of a number of things in astrophysics, in space science. So that can definitely be done. The issue, I think, is going to be to make sure that this platform is that this platform reaches a large enough community to really have a crowd to source the problem, and coordination. Something that this could achieve, for example, is the follow-up that I mentioned earlier, right? So we need this community that would use the crowdsourcing facilities to be connected, so that if something is cited by one person, that message can go across and a broader community can point their sensors to the problem, to the sighting. And the data has to be transmitted to a place that can centralize it and curate it.
Yeah, please feel free to say this is a bad idea. But have you thought about synthetic data? As you were talking, I was thinking, given the fact we don't have enough quality data to train a neural net, if we were to generate synthetic data based on the information we do have and then filling out the other characteristics as we might guess, does that then help us train something to iterate in AI to be able to find other correlations within data as we get it?
So we do it all the time in data science, right? We do generate data sets where the data sets are sparse or scarce, and we cannot train machine learning models. It's a risky business because in the data that we generate, we embed the bias that we have. So we embed our thinking about the data, the way in which we think the data looks, and the way in which we think the anomalies look. So particularly in anomaly detection, it is a very difficult thing to do, to try to make sure that you don't bias your models to what you know.
I want to come back to this topic of anomaly discussion in our general discussion. We're sort of starting to run a little late, so I want to cut off questions now, but we do have a little time later at the end. So don't forget your questions. Bring them up again in discussion, and we'll talk more later. Great. So David's our next speaker.
All right, good afternoon. My name is David Grinspoon. I'm a planetary scientist and astrobiologist, and I'm going to talk for just a couple of minutes about how observations beyond Earth are relevant to our study of UAPs. Many of NASA's missions are, at least in part, focused on answering the question of whether life exists beyond Earth. Astrobiology is the study of the origin, evolution, distribution, and future of life in the universe. As part of this, we consider how to search for biosignatures, observations we can make of other planets which might betray the presence of life. So we look for things like anomalous gases in the atmospheres of planets and other anomalies which may possibly reveal the presence of life. When we discover such an anomaly, we don't conclude that we've discovered life. We seek more data to understand what we're seeing, and often this leads to other new discoveries. Similarly, we can talk about looking for technosignatures, observations we can make which might reveal the presence of technological activity somewhere else. NASA is also supporting some research studying technosignatures. While there is at present no evidence we're aware of suggesting an extraterrestrial source for UAPs, these existing NASA programs are relevant to the question of UAPs in at least two ways. First, researchers in astrobiology and SETI, the Search for Extraterrestrial Intelligence, have focused for many years on techniques and methods for identifying anomalous signatures and determining if they have mundane natural explanations, as opposed to revealing unknown biological or even technological activity.